Hello, I'm Graham Lewis, and in this video we're going to look at analysing your data for your project in your summative data management project. This is the exciting bit. Well done, congratulations. The actual hard work, the heavy graft, is over. You've come up with your driving question. You've designed a really great survey. You've collected data using a pilot study initially, improved your survey, and then you've done a sampling technique and picked your sample and sent your survey out. You've had to send reminders. You've worked really hard to get to this far. Well done. Now it's the fun times. You get to analyze your data and see what it shows you. And this is my favorite bit. You can really get curious about your data. The driving question is key. You want to answer your driving question. So what can you find out? So for this video, I've picked Evas, which was just selected randomly, who's a wonderful student in the class of 2020, graduating, and her driving question is, to what extent do Appleby students believe that use of technology aids their learning, and how is this related to their perception of their learning skills? So let's have a look at Evas Data. So we're going to look at Evas Data very briefly. As we're looking at it, get curious, think, what could I draw box plots of? By what category? What could I draw scatterplots of? By what category? So let's start. Eva's got the categorical data of whether they're in senior school, upper school, or middle school. She also has a ranking question. I'll just move this down here. Rank the following in terms of total time on different apps. She's also got, on a typical day, how much time they spend on a computer. Now, if she wanted, she could turn that into numerical data rather than categorical by taking the mid values and thinking about what to do with the end points. That depends what you want to do. The same with the next question, how long do they spend on their computer and phone on learning? Then they've got my OneNote is organized. I collaborate well with my peers. I plan my schoolwork. Another collaboration one, I don't procrastinate. In general, I think technology is the major reason for procrastination. Then we've got using technology improves my creativity in learning. I believe technology has helped me with my learning. I see technology as an obstacle when I am trying to focus. And now what I'm going to do, and what Eva did, which I think is really smart, she looked at two of the questions which she thought were organization questions. So she looked at E, my OneNote is organized, and she looked at G, I plan my schoolwork and allocate appropriate time, which is also an organization question. And what she did is she averaged those two to come up with an overall organizational skill, which I think is really smart. So you can see here that Eva has got an overall organization skill, which is the average of two Likert type scale questions. I went one step further for this video, and I actually found two technology questions and how overall technology improves learning, and averaged those two. So now I've got two measurements which are averaged from other questions, one on overall organization skills and one on technology improves my learning. And that got me thinking, I wonder how that varies across the grade. So then what I did is I copied into Curiosity 1 just the ones I'm interested in. So I never mess with my raw data too much, because if I mess up, I can always go back to it. So in a new sheet at the bottom here, I've got the grade level, overall organizational skills, and overall technology improves learning. And I want to explore this by the senior, upper, and middle school. So let's first draw some box plots and histograms. So I've placed the data into Fathom, and I'm now going to look and have a look at their overall technology improves their learning. And I'm going to draw a box plot of that and have a look at the whole school. So there we've got an outlier. Eva had a 7-point Likert type scale, and we can see that we've got an outlier, so we need to use the median, and we could describe that distribution. I'm not going to go into that now. I've done that in another video, but that's interesting what that shows there. That clearly, if we've got a 7-point Likert type scale, that 4 is the middle, isn't it? We've got 1, 2, 3, then 4, then 5, 6, 7. And we've got a median of 5.5. I wonder how it varies by school. So we'll grab the school and put that on there. Now we can look at the differences between the middle school, senior school, and upper school. And we can see that there are differences, and we can describe and compare those, which is really interesting. You're just getting curious with your data. One thing that worries me when we subdivide by category into upper school, senior school, middle school is to make sure we've got enough in each category. So I'm going to go back to Excel to check that. Now, Eva has a very nice large sample size. Her row number is very large. If we have a look here, she's got 79 rows, so she's got 78 in her sample. But does she have enough in each category, middle, upper, and senior? So to look at that really quickly, I'm just going to sort the data by grade level A to see how many senior school students, upper school students, and middle school students she has. So I'm going to use the sort feature. So straight away, we can see that we don't have many middle school students at all. So that worries me a little bit. Now let's scroll down. We seem to have a lot of senior school students and a decent amount of upper school students. So I'm a little bit worried about the small number of middle school students, as we only have 8 of them. Now you have a choice. You can either just comment on this and say that it may not be very reliable because we don't have many middle school students, or you could combine middle school and upper school together and call that grade 7 to 11. And that's something else you could do. So that's your choice. And again, you can play with that and find out what you can find out. Now, I haven't gone through how to do the data and the sorting. You can just search for that or ask somebody, and that's fine. Let's now have a look at scatterplots. So I lie. I was going to go on to scatterplots, but I got really curious with this idea of putting middle and upper school together because then it would be more reliable. And when we look at this, we can see what's happened. There is a definite difference, there looks like, between the two distributions between senior school and middle school and upper school. And we know that this is reliable because we've got a really good number in each category. So we can talk about how technology improves their learning and how people perceive that differently in middle and upper school versus senior school. And that raises other questions. Now let's go back to the data and think about scatterplots. So with a scatterplot, you always start with a hypothesis, something that you're curious about. Remember, it's got to be sensible, that you think there might be a reason for them to be related, or you want to prove that they're not related. Remember the example we did on storks and babies, which is silly. So don't do any scatterplots connecting the number of storks in a town to the number of babies. So here's my hypothesis. I hope you think it's sensible. If a student is more organized, they believe that technology overall aids their learning. So I'm thinking that the more organized a student can be might explain their opinion of technology helping their learning. So let's have a look at that. Now, the way I've phrased it is I'm using organization to explain their technology aid in their learning. So that means that organization is the explanatory variable. So that goes on the horizontal axis, and it means that their technology overall aiding their learning variable goes on the vertical axis, is the response variable. That's what we're trying to predict. So let's draw the scatter plot and get it the right way around. So here's our scatter plot. I'm always look at the scatter plot before you put any line of best fit on it. I'm thinking there's not really much of a relationship. Definitely, it seems fairly random to me. I might try and find the R value because I'm expecting that to be close to 0. So I'm going to fit the line just to see the R value. So let me just do that. So I've drawn the scatter plot on Fathom with the line of best fit showing, just to get the R squared value here, which is 0.051. Now, once I've written down the R squared value, notice that the line is going up. That means the R value is going to be positive. So when I take the square root of R squared, make sure you take the positive square root. If the line was going down, my R value would be negative. So you take the negative square root. So I'm now going to remove the least squares line, because you should never have a least squares line on when there is actually no line relationship. And let's have a look at that R value. So R squared was 0.051. I took the positive square root because the line was going up. If it was going down, I would have done the negative square root. And we got a positive 0.23, which shows very little correlation, which we could see from our scatter plot as well. So now we can answer our hypothesis. There's no evidence to suggest that our hypothesis is true. There is no evidence that if a student is more organized, that technology overall aids their learning. Now, that's fine. It's okay to get no relationship. That's what the data is showing. You have an idea, you get curious. But I've gone a bit more curious. We saw that there was a difference between middle and upper school and senior school. So what if I did 2 scatter plots and broke it down by school, and maybe there's a difference there? Let's have a look at that. So to get two separate scatterplots, I need to enter two different sets of collections of my data in Fathom. So the first thing, I'm going to organize this data really quickly. So grab those, sort it by, and I want to sort it by grade level quickly. And so I get my middle and uppers all together and my seniors all together. So what I'm going to do now is copy just the middle and upper school students. So copy those people and put them into a collection in Fathom. And then I'm going to equally copy the senior school students and put them in a collection in Fathom, remembering to keep the titles. So you'll have to keep the titles. So I'll pause the video whilst I quickly do that. So just to show you what I did, I copied just the senior school students, kept the titles, and I did copy just the middle and upper school students, kept the titles, and then I put those into collection 3 and 4 in Fathom. And now let's have a look at the scatterplots. So collection 3 is my middle and upper school students. So I've got collection 3 highlighted, bring down a table, there they are, the lovely middle and upper school students, bring down a graph, and then I want the organization on the horizontal, and there, and then looks like there's no relationship still. Let's quickly draw the least squares line. So I've got the least squares line. Interestingly, the R value, when I worked it out, is actually 0.48, which is actually showing that there may actually be some relationship, very weak, between overall organization skills and technology improves their learning. Let's try it now and compare that to the the senior school students. So I've highlighted collection 4. I'd need to put the data in. Apologies. Now I've got my senior school students in data 4. Highlight it, bring down a table. There's my senior school students. Bring down a graph. Let's do the same and let's see what this is. Oh, that looks really random. It doesn't look like there's any relationship whatsoever. Let's add the least squares line and have a look at the R squared value. So interestingly, there looks like there is a difference between middle and upper and senior, and we have learned something, that there is a very weak relationship between middle and upper, so we could answer the hypothesis for them. But in senior school students, there's no relationship at all. It's showing no correlation. Now what would be interesting, because the upper school students were quite a large number, if we took the middle school students out and just looked at the upper school students, I wonder if it would be stronger again. I wonder if the middle school students are changing that correlation. So that'd be something else you could get curious about. So this is all about getting curious with your data. It's really good fun. You can see I get excited and I could just keep going and going and going, but it has to be related to helping you answer your driving question. So going back to Eva's driving question, to what extent do Appleby students believe that use of technology aids their learning, and how is this related to their perception of their learning skills? We've started to explore that and answer it. Good luck with your projects. Have fun. This is the best bit, where you're choosing which graphs to draw and you're using your statistical skills to analyze the data. Remember to use your knowledge that you've learned in the course. So when you're describing box plots and histograms, use shape, center, spread, and also discuss outliers. And remember, for every scatter plot, to make a hypothesis, draw the scatter plot, find the R value, and also answer the hypothesis. Have you, to what extent is your hypothesis correct or not correct? Okay, good luck everyone. This is really good fun. Don't forget to be resourceful. If you can't do something on Excel or Fathom, you've got Google, you can how to do it, and there's lots of great resources out there that you can look up. And don't be frightened just to play. As long as you don't mess up your raw data, so you copy your data into another sheet, it's great to play and experiment. Good luck everyone, and as I said, this is the fun bit. Just get curious with your data.